Hello, my name is Jim Olson, and this is a calculus video in which I'm going to show why the derivative of sine is cosine. I'm going to be showing this on GeoGebra, so let's jump right over to GeoGebra. Here we are at geogebra.com, and I'm going to do this kind of live here because it's really quite easy to do. This is not really an introductory video on how to use GeoGebra. I have other videos that do that, but I'll just show you how easy it is. So we want f of x equals sine x. And the nice thing about GeoGebra is you type that in the same way you would write it on a piece of paper. And what I'm going to do is I'm going to have a point on the curve here that is going to be following along the curve. And of course, we want to call the point P. So I'm going to go to the settings or the properties of that, and I'm going to call it P, and we're going to make it purple because we like purple. Okay, so let's just make sure that this traces on it. It's a point on the curve. And now I want to have a tangent line. So to do tangents, that's going to be found right here in this menu in GeoGebra. This is where we construct our perpendiculars, our angle bisectors, and our tangents. The nice thing about GeoGebra is it tells you right on the screen what you need to click and in what order. It says down here at the bottom that I need to select a point or line, then a circle or a function. So I'm going to do the point first, which is my point of tangency, and then I'm going to click the function. So this is my tangent line. Now I'm going to get out of the tool, and I'm going to see if this is working. Very good. I can see my tangent. I like to call this the surfing derivative. It's kind of like a surfboard. Now I want to have the slope of this line. GeoGebra is nice because it'll do measurements for you, including measuring slope. This is the measurement tool. You can measure angles, lengths, and here is slope. And you see on the screen that all you need to do is select a line. Boom. And here is the slope. And the nice thing about this is that slope is rise over run. And so if your run is 1, then the rise is in fact the slope. This has a slope of 0.68. This has a slope of 54/100ths. And so we can experiment here. We can get a slope of 0 up here at the top, as you can expect to happen in calculus. Here is a negative slope. It looks like I can achieve a slope of -1, then some negative values closer to 0. Down here, the slope is going to be 0, and so on. So this is showing the slope. This means it's showing the derivative. 0.67 is the derivative of this function at the point P. So here's another case. For this particular x value happens to be -1 for input. The slope is 54/100ths, which means the derivative of sine at this particular point is 0.54. Now what I would like to do is I would like to graph the derivative. So I'm going to have another point here. I'm going to call it point Q. And it's going to be the ordered pair x of P, comma, M. X of P means the x value of point P. In this particular case, it happens to be -1 at this moment. And M is in fact the slope. Nice thing about GeoGebra is it does everything geometrically and algebraically at the same time. So when we graph this line, its point G And in fact, it's also a function, g. All right, so right here is point Q. And let's change that just a little bit. I'm going to go to the settings of point Q. And let's make it red to kind of have it, make it stand out. And also let's show not just the name of the point, but let's show the name and value. The value of a point is going to be an ordered pair. Okay, very good. So let's experiment with this and see how well it works. So we have right here point P and point Q, and the slope is 0.19, and the y value of Q is 0.19. Right here at x equals 0, the slope is 1. It's a thing of beauty. When the slope is 1, rise and run are the same. We should be able to get a slope of 1 over here also. It's a little bit off the screen. There we go. Rise and run are equal. That means it's a slope of 1. This is a little bit below 1, and this is a little bit above 1. So this has a negative slope. So when we graph it, we're going to have this ordered pair with a negative value. Now what I would like to do is trace this out. And GeoGebra has a nice trace feature. And so we're going to come to point P here, and we're going to go to the settings or the properties of point Q. And right here is trace. It's going to leave a rabbit trail. Let's see how well it works. Point P is my draggable point, and we can see that we are tracing out the derivative. We're tracing out the slope values. The slope is getting smaller, smaller, smaller. When P gets up to this top point, the slope should be 0. Right there. And now the slope turns to negative, and it's a thing of beauty. Right here, we have a slope of -1, so the derivative is having a minimum there, and so on. This is tracing out the derivative. Now, if we look at this red curve, what do we notice? This is, in fact, the cosine curve. The green one is sine. The red one is cosine, starting at a value of 0,1. It's positive in the first quadrant, going to 0 here at pi over 2, negative in the second quadrant, negative in the third quadrant, and positive here in the fourth quadrant. It's a thing of beauty. We could do a lot more with this. We could talk about inflection points and concavity and so on, but I think maybe that's enough at this particular point. This has been a video on why the derivative of sine is cosine. This is not a proof that the derivative of sine is cosine, but it's a visual reason and a conceptual reason why it is true. Check out my other videos if you want to. On YouTube, I'm Dr. O314. Have a great day.